Okay, Math 10C, so we are now on to 4.6, and in this video we're going to be applying exponent laws. So up to this point we've learned tons of exponent laws. These are all of the tools that we have in our toolbox that not only have to do with exponents but also have to do with radicals, and hopefully by this point we understand that those two things are actually indeed related. Now, in this video, we want to learn how to simplify expression utilizing exponent laws and rules. So how can I use all these rules? And additionally, these rules, and these rules you have seen before. We've actually done these, hopefully in grade 9, but I'll go over a few examples with them anyways. And then solving equations involving exponent rules and laws. So again, we've seen these before. These are all of my other videos from 4.1 up to 4.5. So let's look at the few last final exponent laws that you need to know. Some of these laws you've already seen, such as this one, okay, and this one. These two are pretty much the exact same, or never mind, not the exact same, but they're very related, okay? And then some of these we might just have to learn quickly, and that's okay. So let's focus on our subtract exponent law. So here, this is when you have similar bases. So recognize you have A, and they are similar. At that point, we have M and N as their exponents. Since we are dividing two bases, so A and A that are the same, we actually can just subtract their exponents. So A to the power of M over A to the power of N. Well, we can actually make this a single base of A, and then it would be M minus N. Okay, it's very closely related to our multiplication one, where if you're multiplying, you actually add their exponents. So when you're dividing, you subtract their exponents. So let's see a few examples here. So in this case, you have 2 and 2 as a base. So since you both have similar bases, then we can go 2 to the power of 5, dividing 2 to the power of 4. We can put that as a single base, okay, and take their exponents and do 5 minus 4. So that will equal 2 to the power of 1. Okay, it's very similar in the fact that some people say that they have 2 to the power and 4 in common. Now we can also represent this in a different way. You could think about it in the way of 2 to the power of 4 times 2 equals 2 to the power of 4, right? Because that's how you can express 2 to the power of 5. It's simply 2 to the power of 4 times 2, because remember, this has a little exponent of 1. And then you can have these guys cancel out and you're just left with 2. I would suggest maybe going about this way. Definitely learn your exponent laws because it can save you lots of time. Now remember, variables are simply just numbers. We just don't know the exact number. Okay, it's a placeholder. So the laws that apply to numbers also apply to variables. We just have to have similar variables. So here we can see that we have z to the power of 5 times x dividing x to the power of 2 times z to the power of negative 3. In this case, recognize that, remember, multiplication is commutative. So 4 times 5 is the same thing as 5 times 4. So since everything's multiplying here, we can represent z to the power of 5 times x as x times z to the power of 5 over x squared times z to the power of negative 3. And then from here, we can apply our laws. So wherever we have similar bases, okay, wherever we have a similar base and they're dividing, we can simply subtract their exponents. So here, x and x are similar bases. Remember, this x variable actually has an exponent of 1. So what we can do here is we can do a single x variable and we can do 1 minus 2. Remember, it's our numerator's exponent minus our denominator's exponent. So x to the power of 1 minus 2. Now we have z to the power of 5 minus, and recognize this is a negative 3. So I can represent this as negative 3. And then from there we can combine. So x to the power of 1 minus 2, well, that becomes x to the power of negative 1 times 5 minus negative 3. Remember, 5 minus negative 3 is actually 5 plus 3. Because two negatives make a positive, and that becomes 8. So we have z to the power of 8. Now, recall that we don't really like representing things with negative exponents. So we are going to use our law up here where if we have a negative exponent, we can take the reciprocal. So that was last video in 4.5. So I'm going to represent this as z to the power of 8 over x to the power of 1, or simply just x. And there's my simplified solution. Okay, so that's us applying our subtraction exponent law. Let's go to the power of a power law. So to the power of law, this is where you have a single base and you have an exponent, and that exponent is also to the power of something. When this happens, you actually simply just multiply their exponents. Okay, so here we can see that's 2 to the power of 2 to the power of 3. So here, in this case, since these two exponents are both applying to 2, what we're going to end up doing is we're going to end up doing 2 to the power of 2 multiplying 3. 2 times 3 is 6, so this will be 2 to the power of 6. And we could simplify that, 2 to the power of 6. Let's check here. 2 to the power of 6, we should know that that should be just 64. So 2 to the power of 6 equals 64. So if we had a calculator, we could do brackets 2 to the power of 3, bracket, let's get that out of there, bracket to the power of 2. And you're going to notice it's the same thing, because again, these are the exact same expressions. Okay. So let's move on to example 2 here, where we have x to the power of 2 to the power of 4, x to the power of 3 to the power of 6. So here, recognize I have similar bases dividing each other. But at the moment, I should simplify these exponents first. So I'm going to apply my power of a power law. So here, I'm going to do 2 times 4. Okay. So this will be 2 times 4. So that top number will become x2 times 4, and that bottom number I can also apply my power to power law. So that'll be 3 times 6. So this will be x to the power of 3 times 6. Now 2 times 4 gives me 8. So this will be 8x to the power of 8 over 3 times 2, which gives me 18. So this will become x to the power of 18. And then from there, I can actually further simplify this. So now we know how to use this law over here. A to the power of n over a to the power of n. You subtract their exponents. Here I have similar bases, x and x. So I can represent this as a single base, take my numerator's exponent, and subtract it from my denominator's exponent. And that will give me x to the power of 8 minus 18. That gives me x to the power of negative 10. Now remember, we don't like leaving our exponents as negatives, okay? It'll be much easier moving forward to learn how to always put these into a positive exponent. So I'm going to apply my reciprocal negative exponent rule from 4.5, and that's going to be 1 over x to the power of 10. And there's your solution for that one. Okay, let's move on to this rule here. So this is known as the power of a product. So when you have two numbers multiplying each other to the power of m, you simply just bring in your exponent and multiply a to the power of m and b to the power of m. Okay, so each thing gets applied to that exponent. This only occurs when you have brackets, okay? And so 3x to the 6 does not equal 3x to the power of 6. These two things are not equal, okay? Because this one, your x to the power, your exponent of 6 is only applying to the x. Here your exponent of 6 is applying to both. Okay, so just recognize that. This is wrong. So here, since I have two entities multiplying each other, and they're both being applied to the same exponent, I'm going to bring that exponent in. So this will become 3 to the power of 6 times x to the power of 6. Okay, and 3 to the power of 6, I'm not quite sure what that is, so let's plug that into my calculator. So again, I'm going to use my exponent. So to the power of 6, and that gives me 729 x to the power of 6. And there's your solution there. So there is it in a more simplified fashion. Now here, we have three variables. Nothing changes. All of these are being multiplied by each other, and each individual thing is being applied by the exponent. So here I'm going to bring that exponent in, and this will become 5 to the power of 7, x to the power of 2 to the power of 7, y to the power of 7. Okay, so 5 to the power of 7, let's figure out what that is first. So 5 to the power of 7 will become 78,125. Now, how do I simplify this? Well, the way I'm going to simplify x squared to the power of 7 is I'm going to use my power law. So here I have a single exponent, and it has, a single base, which is x, and it has two powers. So what do I do with those two powers? I multiply them. So this will become 2 times 7, which will become x to the power of 14, and then y to the power of 7. So there's my simplified version. Something else I really want to hit on here, and this is super important. So let's say I have x times y squared. How would I deal with that? So definitely write this down. So note, I have x times y squared. Well, here I'll apply the power law. That will become x squared y squared. Now what happens when I have x plus y squared? This is where people start to become confused. They simply feel like they can apply this exponent inside. But with polynomial rules, which we've learned before, this will actually become x plus y times x plus y. And then from there, you're going to have to FOIL this out. So x times x times y times x, y times y. So you'll end up getting x squared plus 2xy plus y squared. Okay, I didn't overly explain that because at this point you should know how to do that. And if you don't, you can go watch the other videos that I have about this. Just recognize that when you have an addition or subtraction symbol involved and everything isn't just multiplying, then that power rule does not exist. You have to actually expand as soon as you have an addition or subtraction value. Okay, so let's go on to our last one, which is the power of a quotient rule. And this is very similar to the power of a product rule. Okay, in this case, when you have an exponent and everything is being bracketed and you have a quotient inside, which is just a fraction, that exponent applies to the numerator and the denominator. So what is this going to look like here? This is all being bracketed and you have 2 over yz squared. And that whole thing is to the power of 3. So this 3 is going to go and apply to every single thing. This will become 2 cubed over y cubed z squared to the power of 3. 2 cubed, hopefully we know by this point that is 8. Y cubed simply just stays as y cubed. Here, z squared to the cube, well, we're going to have to apply a power of a power rule. M and n multiply together. So here, 2 times 3, so that's going to give me 6. So this will be z to the power of 6. And there's our simplified form. Okay, let's look at our last example here. And this should say example 2. Okay. And let's go over this one here. So it's very similar. We have a power, okay? We have a quotient in here. And then we have a power, okay? Everything is being bracketed, so that means this power of 2 is being applied to every value inside here. So we're also technically applying this one as well. We have 3 times z squared, so we're going to have to apply this power 2 to both values, okay? So let's do this. So this will be 3 squared times z squared to the power of 2 over x cubed to the power of 2, y to the power of 2. So hopefully we see we've applied this power to every single thing in our quotient, okay? And now from there, we are going to just simply, I don't know why I wrote y there, we are now going to simplify. So 3 squared, that is 9. I apply my power to a power rule, so 2 times 2, which is 4, set to the power of 4. I'll apply my power to the power rule, 3 times 2, which is 6. And then y squared. And I can't simplify anything further because all of my values I have are all different variables and numbers, okay? So I'm gonna stop at this point because the next few examples will take a little bit and they're a little bit more involved, okay? But this next video in part 2, we are going to be applying all the rules we have into one, okay? So make sure you're practicing a lot. Maybe just go practice these simple ones first, okay? Kind of as a little review to get ready for the next lesson.